Hello, this is Nature Nerd 1000, and today I'm going to show you how to do ancient binary base 8. And basically, the Indians, they originally used like the palm of their hands or like the knuckles, because we have like 8 knuckles or 8 like palm of the hands in between. So like 1, 2, 3, 4, or 1, 2, 3, and then 4, and then on the other side like 5, 6, 7, like 8. And basically that's how a lot of ancient cultures counted, actually. Like they using like base 8, like the knuckles or the palm of their hands. And so I thought that base 8 is best represented with dots. Since it's like connected to the hand and the fingers, then basically it should be vertical, so it's vertical dots. And basically the original ancient binary base 7 system was like horizontal dots like that. So ancient binary is vertical dots. And the next thing is, in vertical systems, in ancient binary, it is perfectly acceptable to use as a blank straight line for like 0 if they want to. And so we start off with 1, which is a dot in the 1's place, 2, then 3, 4, 5, 6, then we have 7, like that. So next we move on to 8, which we would go to our first 0, one set of 8. You could also write 8 like this too, if you want to, but like I said, it is perfectly like acceptable to write just a blank, like straight vertical line if it's in a vertical system. So we're going to do a couple more examples up to 16. So 9, 10, 11, let's see, 12, 13, 14, and 15. There we go, that's 15. And so now we go to 16. 16 is basically 2 sets. And like 17 would like look like that. Next we're gonna count by 8s. So 24. So yeah, 24, there's then 3 sets. 32 is then 4 sets. And 40. 48. 56. 64. We get into the 3 placeholder. We ran into an engineering problem because on the original ancient binary base 7 system, it was like a line to like separate, like a vertical line to separate it, and then on the other base systems it's just fine to do a dot. So 2 new symbols had to be engineered for a comma and as well as the dot. It's logical too. And it follows alongside of the division, multiplication, subtraction, and addition features because they're because these are sideways arrows, like a lesser or greater than. So this is like for the math problems, but then the new symbol for comma, and by the way, you can still use the reverse system we have today. For the comma extended number, it is like a greater than symbol. So like, this is like higher numbers. Higher numbers is like a greater than symbol. This is like a separation for a large number. And then basically if you want like a fraction or small number, it is then a lesser than symbol. And this goes into this system and I think it's logical. I really like it now. So basically you would draw a small one of these once you get into the 4 digits, and then that fixes the problem of like separating like large numbers, and it also fixes the problem of the comma like reverse situation. So the next digit is 512, because 64 times 8 is the next placeholder. And then this represents that this number keeps getting higher. And then that's 512. And we're going to go a couple higher. And the next digit you would do is 4096. And so once again, basically a higher number. And then we'll do 32,788. The last one we'll do is 262,336. 7 places. And there we go. So this is the ancient binary base 8 system, and I really like the new comma and dot system. And if you want to, you can still use the reverse system, because it is more efficient sometimes. But for this base, this design, this symbol had to be engineered. I don't know, if you wanted let's say you wanted 0.1 for example. This is like a fraction low number. So if you wanted 0.1, you would use the lesser than symbol. And then basically this would be a fraction in the new ancient binary system, where this is for like low numbers, like, or not whole numbers. And I hope you enjoyed the video. This is Nature Nerd 1000 signing off. Bye everyone.